Scientists and philosophers have spent centuries researching and discussing the vast and diverse subject of the universe's history. The Big Bang Theory, which proposes that the universe began as an incredibly intensely hot and dense explosion around 13.8 billion years ago, serves as the cornerstone for our current understanding of the universe's history. In this video, we will explore the history of the universe in a nutshell. The universe is the total matter and energy system of what we see and know today, of which Earth is a component. Its fundamental constituents are galaxies made up of stars, stellar groupings, and nebulae. The Milky Way galaxy includes billions of stars, including the Sun on Earth. The universe contains all atoms, subatomic particles, and their constituents. The four fundamental forces that govern the universe are the weak force, strong force, gravitation, and electromagnetic force. The Cosmic Background Explorer satellite's instrumentation revealed in 1992 that 99.97% of the universe's energy was emitted in the first year following its birth. This information appears to support the Big Bang Theory, which states that the universe was created by one cataclysmic explosion of a minuscule amount of intensely hot and dense matter known as the Big Bang. Astronomers believe that 99% of the universe's matter is dark matter, which is made up of dark or invisible matter that is hard to find. The details of what happened at the moment of the Big Bang are not subject to any commonly accepted theory. Using current physics theories and principles, we can deduce that the universe had infinite temperature and density at the precise moment of creation. This implies that no physical theory can explain what happened during this period. In the first minute fraction of a second after the Big Bang, the universe went through a phase of tremendous expansion known as inflation. The most plausible hypothesis is that the cosmos appeared and then expanded at an extremely high rate in the first minuscule fraction of a second. The cosmos has continued to stretch and cool since then. Due to the high heat and density, the universe was built up of a few distinct particles in this minute fraction of the first second. You've probably heard about the recently discovered Higgs boson, which can be seen for a split second in the harsh conditions produced by particle accelerators, like Switzerland's Large Hadron Collider. These are not visible under normal circumstances. The Higgs boson most likely existed in the first minuscule fraction of a second of the Big Bang. Even though the temperature was close to 1 trillion degrees Celsius, the universe began to cool and expand swiftly as soon as it reached a second old. As a result of this expansion, the universe cooled and stretched, resulting in the formation of subatomic particles such as protons, neutrons, and electrons. Because atoms cannot exist at such extreme temperatures, neither of these particles could link to form atoms. Approximately 10 seconds after the Big Bang, the universe had cooled to 1 billion degrees in temperature. This temperature is suitable for the existence of atomic nuclei. The universe served as a giant nuclear reactor. Hydrogen nuclei became converted into helium nuclei in 3 stages. The reaction has 2 unique pathways, yet both lead to the same result. 2 protons and 2 neutrons unite to form a helium nucleus, which emits a large amount of energy. Finally, these particles bonded to form atoms, predominantly helium and hydrogen. The universe became translucent due to the absorption of free electrons during this phase, known as recombination. The light emitted at this epoch can now be detected using the radiation from the cosmic microwave background. However, before stars and other light things were formed, there was a period of darkness following the recombination phase. The universe constantly evolved over the next billions of years. In the early universe, the matter was drawn gravitationally to higher density regions. This gravitated matter subsequently became galaxy clusters and elongated filaments of gas and dust, resulting in the breathtaking filamentary cosmic web seen today. As the universe expanded, matter began to build up due to gravity, giving rise to galaxies and stars. There is still a lot to understand about how galaxies, which contain hundreds of billions of stars, originate. The bottom-up theory, which has recently acquired popularity, is one such theory. According to this theory, a gas cloud in a galaxy collapsed into a yellow star with a ring system surrounding it. These rings eventually merged to form the star system that we live in today, including the 8 planets and several moons, comets, dwarf planets, and asteroids. This theory either resulted in Earth, the planet third from the central star retaining a considerable amount of water, or comets subsequently transporting a flood of ice and water to the planet. A lot of small galaxies constantly get swallowed up by larger ones as the universe expands. The Sun and our solar system's 8 planets, including Earth, originated around 4.5 billion years ago. Our solar system originated approximately 8.9 billion years after the Big Bang, giving it an age of about 4.5 billion years. The Sun circles around 24,000 light-years from the galaxy's center and is one of over 100 billion stars that comprise our Milky Way galaxy alone. Many scientists believe that the solar nebula, a vast spinning cloud of gas and dust, was responsible for the development of the Sun and the rest of our solar system. And as gravity caused it to compress, the nebula began to spin faster and flatten into a disk. Throughout this phase, a bigger portion of the material was drawn into the center, resulting in the formation of the Sun. Our Milky Way galaxy is said to have formed a little more than 1 billion years ago. Smaller galaxies that the Milky Way has absorbed throughout its long existence are still there as remnants within the Milky Way. The Milky Way is actively digesting at least 2 tiny galaxies, and possibly more will get dragged in over the next 100 million years. Old stars, also known as population 2 stars, are found in a halo surrounding the Milky Way and primarily contain hydrogen and helium elements. The heavier elements were possibly discovered in the early population 3 stars that exploded. Planets are formed when the byproducts of materials of star creation are combined. Rocky planets like Earth, Mars, and Venus cannot orbit population 2 stars because elements like iron, oxygen, and silicon are only present in trace amounts. The Sun and other younger population 1 stars can be located in the disk and the bulge at the galaxy's center. These have a higher concentration of heavy elements and are expected to be host to numerous planets. Over the next billion years, stars and galaxies continue to form and change. Some stars eventually ran out of energy and died, triggering nuclear fusion and the production of heavier elements. These heavier substances, such as iron, oxygen, and carbon, eventually created planets and other planetary systems. The Earth's environment eventually improved to the point that life could flourish, allowing single-celled organisms to emerge initially, followed by more complex living forms such as plants and animals. The current diversity of life is the consequence of many different diversities of life evolving and becoming extinct as the planet's climate and environment change over time. Humans are one of the most recent species to originate on Earth, with a roughly 200,000-year history and noteworthy achievements in culture, science, and technology. Astronomers began to theorize in the 1960s and 70s that the universe may contain more mass than what is seen with the physical eyes. Vera Rubin of the Carnegie Institution of Washington measured star velocities in various galaxies. Rubin detected no difference in the star's velocities further out, contrary to what fundamental Newtonian physics would predict, if stars in the core and periphery of a galaxy orbited at different rates. She noticed that each star in a galaxy appears to orbit the center at a fairly constant speed. This mysterious and unseen mass is known as dark matter. Dark matter is said to exist due to the gravitational influence it has on other types of matter. The unknown mass is said to be formed by distinct particles that do not interact with light or ordinary matter, explaining why it has been so challenging to detect. According to our current understanding, the universe appears to be expanding and speeding up. The speed is currently assumed to be caused by a mystery component known as dark energy, while scientists are still striving to determine its exact origins. astronomer Edwin Hubble made a groundbreaking breakthrough about the universe in the 1920s. While utilizing a newly developed telescope at the Mount Wilson Observatory in Los Angeles, Hubble determined that the universe is expanding rather than remaining static. Years later, in 1998, the Hubble Space Telescope, named after the famed astronomer, determined that the universe used to grow more slowly than it does now. Scientists were taken aback by this discovery because it had long been expected that the universe's gravitational force would cause it to slow down or possibly stop expanding. The mysterious and unexplained dark energy is said to be the strange force pushing the cosmos apart at breakneck speed. The presence of this unknown energy, which is said to make up 80% of the universe, is one of the most fiercely disputed subjects in cosmology. Well, the story does not finish there. The history of the universe is one of development and change, from the hot, dense singularity of the Big Bang to the formation of stars and galaxies, and finally to the appearance of life on Earth. Scientists are still studying and trying to understand the universe's history. Despite the quantity of knowledge collected, many mysteries about the universe's origin and evolution remain unresolved. Even though dark matter and dark energy remain among the greatest mysteries, cosmologists continue to explore the cosmos to discover more about how the world came to be. In one conceivable future scenario, the universe will keep expanding endlessly, long enough for all the stars in all the galaxies to run out of energy and even black holes to fade into oblivion, leaving behind a lifeless universe full of inert energy. Or the gravitational pull will finally overwhelm the expansionary force of dark energy, bringing all matter back together in a process known as the Big Crunch, which is a form of reverse Big Bang. Dark energy could also hasten the universe's dispersion, resulting in the Big Rip, in which the universe splits apart from the inside out. In addition to continuing to search for elusive dark matter, the James Webb Space Telescope, which launched in 2021, will also use its infrared instruments to look into the past and study the evolution of the universe. We can better understand the universe's origins and evolution by studying its history, which is an interdisciplinary subject that draws on the study of physics, cosmology, astronomy, geology, and biology. And that brings us to the end of this video. How do you think the universe will end? Let us know in the comments section. Remember to like, subscribe, and click on the notification bell to get notified when we post a new video.